How much memory can a 64-bit machine address at a time? If the memory is byte addressable, shouldn't it be 2 to the power of 64, 2 to the power of 10, 2 to the power of 10, 2 to the power of 10, equals 2 to the power of 34 GB? A general Google search says 8 GB or 16 GB max. How is that true? Also, how does it depend on the operating system?
There are multiple interleaving factors. First of all, you are currently unable to assemble a system that has 264 bytes, 16 exabytes, of physical RAM. Second, just because an architecture uses 64-bit pointers, doesn't mean that all the bits of those pointers are actually used. Notably, current x86 64-bits, aka M64 and Intel's current 64-bit chips, actually use 48-bit address lines, M64, and 42-bit address lines, Intel. See this URL, theoretically allowing 256 terabytes of physical RAM. Second, motherboards have their own limits on how much RAM they can support, both physically and logically. Physically, there are only going to be so many slots available for RAM. As for the logical limits, I don't fully understand why this is still the case for x86 64, the memory controller having long since been migrated into the CPU itself, but there it is. Presumably corners are being cut on address lines to save a few bucks in design and manufacturing. Third, an operating system may have internal limitations as to how much RAM it can efficiently support. In part, this is actually to prevent needing overly large data structures to keep track of usage for memory that isn't really there. Last I checked, Linux allows 128 TB of virtual address space per process on x86 64, and can theoretically support 64 TB of physical RAM. Fourth, some operating systems, for example Windows, will artificially limit how much RAM can be used as a tactic to make users upgrade to more expensive versions if they want more RAM. Windows 7 Starter is limited to 2 GB, Home Basic to 8, Home Premium to 16, and Professional and above are 192 GB, and Windows Server releases have far higher limits.
If you use MS Windows, the maximum memory is constrained by the operating system. For Windows 7, the maximums are Starter, 2 GB, Home Basic, 8 GB, Home Premium, 16 GB, Professional, 192 GB, Enterprise, 192 GB, Ultimate, 192 GB. Windows Server 2008 ranges from 8 GB for entry-level to 2 TB for the top of the line. See this URL for a fullish list. These limits are primarily for marketing reasons. By restricting the cheaper versions, they make the high-end versions, comparatively, more attractive. I think that recent Linux builds work with around 32 TB of RAM, although not all hardware can support that.
A 64-bit machine should be able to address up to 264 addressable units. In architectures designed over the last few decades, addressable units are invariably bytes, aka octets. If you define a gigabyte as 230 addressable units, then yes, 234 gigabytes would be another way to express the same count. What Google search produced those ridiculous tiny results? Maybe the page you found was talking about the amounts of RAM you can buy in reasonably cheap boxes of a certain model. You can most definitely have much more RAM, all addressable, of course, even in boxes that are far from being very costly. Operating systems most definitely can, and do restrict the amount of addressable memory. For example, they can do so by limiting the size of page tables, perhaps to some configurable maximum, that can be set by recompiling, or otherwise reconfiguring the OS. It's hard to be more specific without focusing on some specific group of OS.
You can have as much RAM as you'd like, but it all depends on the operating system and the application you're running, as someone else stated. If you're running a hungry CPU-intensive application that's also intensive on other hardware like your hard disk, then you best seriously consider a second CPU, in a completely separate machine. For example, running a database application and email server both on separate machines. It doesn't matter how much memory you have, in today's market the whole system will grind to a halt. Single CPUs simply can't handle the multitasking the way you'd expect. For a single machine with loads of memory it's better but not that brilliant if you have multiple applications running on the same system, regardless with the amount of memory installed. This is the very reason why big companies use not only 64-bit architecture to address more memory, but they also load balance the whole lot with 2 or more servers. If you're really serious about performance, then definitely go 64-bit, but also consider load balancing with a second server. I've been down that road, configuring a single machine with maximum RAM. Yet when running multiple applications it still runs like a dog. That's because the CPU itself just can't handle it. My advice is to save your bucks on memory and purchase a second server and then load balance the two. It's a lot simpler, plus, once you get into the grips of it, it's easy to expand when you need more processing power and speed. Also, a 64-bit architecture machine can cope with 32-bit software, but with a 32-bit machine you're limited to only 32-bit or less applications, including the operating system. Since the whole market is going 64-bit in terms of both hardware and software, I would advise to go 64-bit for the long term, but forget the idea of squashing all onto one single machine with bucket loads of memory, because you'll be disappointed. If you are uncertain what load balancing is, then Google it.